I think that problem 2 TAC 83, which is our next one, is another graphing problem. Yep. So let's go ahead and skip that one and move to 2 TAC 84. All right, 3 parts. Man, these guys with their 3-part, 4-part, 5-part questions. So, 2 TAC 84, determine which of the following pairs of triangles are similar. Justify your answer. Okay. So what does it mean for them to be similar? We don't really care about their side lengths to some extent if we can get all their angles. Otherwise, if we can't get their angles, so down here we don't know the angles. If we don't know the angles, then their sides all have to be a constant ratio. Okay? So let's start with A. So we've got 60 and 40 over here. And what would the other side length be? Well, let's see. 60 plus 40 is 100, so the other side length will be 80, because there's 180 degrees in the triangle, so 180 minus 100 is 80. Well, here we know they're not similar, because this one has 60, this one has 85. It would need 80 here and a 40 here to be similar. So, A is not similar. A, not similar. Okay? Boom. How come it keeps changing the font on me? Alright. Anyways. B. Let's take a look at B. Okay. Ooh, interesting. Alright. So we've got 50 degrees on this side. We've got 45 degrees on this side. And we're not sure over here. On this side, we've got 50 and 85. Okay. Well, let's see here. So we know it has to have 180 degrees, right? So if it's 50 plus 85, 50 plus 85 equals 135, okay? So then the missing angle would be 180 minus 135, which equals 45. Okay, so 50 plus 45 plus 85 is 180. 50 plus 45 plus 85 equals 180. So this angle is going to need to be 45. This angle is going to need to be 85, which looks like all the angles are similar, or are the same rather, which means that the sides must be similar. Cool. So all the angles are the same in the triangle, then all the sides must be similar. They won't be congruent necessarily. They won't be the exact same, but they will be a multiple of each other. Cool. So A, similar. Or sorry, B, similar. And now we are on C. Let's see what C is. Okay, this one's a little tricky because we don't have any angles now. 0 angles. Oh no. So that means that if these two triangles are actually similar, if one of them is just a scaled version of the other one, either scaled up smaller or scaled up bigger, if they're similar, then there will be a constant ratio between all of the sides. So let's look at the corresponding sides. So this side is 12, that corresponds to the 6. This side is 16, that corresponds to the 8. This side's 14, that corresponds to the 7. So what's the multiple to get from 12 to 6 or from 6 to 12? Well, if I go from 6 to 12, 6 times 2 is 12. Boom. So if the multiple here is 2, 6 times 2 is 12, and all the sides are the same way, then the two triangles are similar, because this is just half the size of this one. So let's see what this side is. This is 8 times 2 is 16. Boom. Ratio of 2. What about this one? This one's 7. 7 times 2 is 14. Boom. All right, so this triangle is half the size of this one, and it's a similar triangle. Okay? All right, so similar. Dun, 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 dun. All right, and that was it. That looked a little intimidating at first, turned out not to be that bad. All right, well, I miss you guys. I look forward to seeing you next week, and hopefully that math wasn't too challenging or troublesome, and I will make another video for you guys tomorrow. All right, I'll talk with you later. Bye-bye.